everybody? It's Friday night, my friends. And I'm back, and we're gonna jump back in to some coding stuff tonight. Let's see if I can get that up there. There we go. Very good. Very, very good. Did I adjust this properly? It's gonna have to be how it's gonna have to be. Welcome on in, everybody. Welcome. So yeah, I thought so. Normally I'd be doing the streamer bot tonight. Oops, that is that one there. But we're at a point where I just kind of really need to sit down with it and like hammer through the stuff that I was going through with trying to get the multi-streaming working through it. So I just kind of need some time to like just sit down and just really look at it when I can. So I thought it'd be good, since we made some progress with our Vulkan rendering engine. Well, we made progress through the book that we're following, and there's still a bunch more chapters we have to get to before we can actually get something on the screen. I thought it would be good to just kind of continue with that progress and just keep pressing forward here. Maybe, I mean, I don't think I'm going to get all the way to the end of chapter 5. We finish up chapter 2. But maybe I can get a decent way along, at least. Anyway, so we'll see how it all goes there with that. Welcome on in, Tech, as well. I know you're lurking, so lurk on. Anyway, let's see. So let me think here. So I want to get this. So I need to look at the chapter 2. So chapter 2 is what we finished. Yeah, chapter 2 is what we finished. So now chapter 3, if I'm not mistaken, is... Yeah, no, so I think we can go straight through chapter 3 as is, just like we did with chapter 2, because this is setting up like physical devices and stuff. And then I think chapter 4 also is a straight line, I think, because this is setting up the swap chain stuff for swapping images in and out, double buffering and all that fun stuff. So I think that's good. I think it's chapter 5 and chapter 6 is where we have to start like combining things, because chapter 5 has us clearing the screen. So we'll do the part that clears the screen at least. And is that all it does by the end of it? Because I feel like at some point they start... Okay, so no, chapter 5 we just go straight through, because all it does is going to give you a clear screen, which is fine. I think it's where after we get to that things we have to like... I think we have to combine sort of chapter 6 and chapter 7, or maybe even just skip 6 to go to 7. It's going to have to be a combination of both, I think. Because 6 is drawing triangles, but it's just doing it like on its own, and I think at the end you draw your own like something here, and then I think, is it 7 where they actually get into loading? Yeah, going 3D. So this is doing shaders and stuff, but they're doing their own shaders, I think, right here, doing their own 3D model. So it's going to be probably, I guess, skip chapter 6, or at least look at what is built on in there, And I think it's like chapter 8 is where they start. Yeah, complex models and textures. So this is where we start to get within parity of the OpenGL stuff. So that's where we start to get to the more interesting parts of this, where all the foundation work is done. In the meantime, chapter 3, physical devices, is what we got to do right now. Set up a physical device and a surface. Okay, physical device selection. Physical CPU. You can have several Vulkan capable physical devices, more than one GPU, but you usually just have one. We're not going to deal with multi-GPU rendering here. Good. Define many concepts. Define class diagram. Okay. Selecting and creating a physical device in a new class called Phys Device. One Vulkan device. In order to get the most appropriate one, this class provides a static method to do that selection and construct the associated object for it. This method, called create physical device, iterates over all the available devices and picks the most suitable one. Okay. Looking at the capacity. Okay. Start by getting a pointer with a list of available physical devices. Once we get that list of no suitable devices, we just throw a runtime exception. Yeah. Start a loop to iterate over that list and create a VK physical device instance for each of those handles. Okay. Create physical device, number of devices. Oh, here we go. Has graphics queue family, has KHR swap chain extension. Okay, so that's where we're actually testing to see if it's compatible. We check for two things: that it's capable of supporting the graphics queue family, and that it's capable of presenting images to a screen. Okay. Right, because you don't want just a computing GPU. You want something that's attached to a physical rendering device. Okay. Once we finish the loop, we have not selected a device yet. We just picked the first one from the list. You can add more to this to get the most capable one, but this moment the approach should be enough. If no device has been selected, we throw another runtime exception. Okay. Get physical devices. Enumerates available physical devices. Receives a Vulkan instance and an int buffer when number of devices is returned. Okay. Device properties such as device name, the vendor, its limits, device extensions of buffer, support extensions, queue families. Constructor populates these structures with the exception of VK physical device, which is passed as a parameter. Okay. I see. So it's got a static method to help populate it. I mean, it's okay. Sure, and then and then you create an instance of it with the actual physical device that you want. Sure. I don't particularly like that. I know why they did it that way. I don't particularly like it. I think I'll probably have a utility class that just has that static method in it that returns a physical device, and then I can pass that. It returns a VK physical device, I should say, a Vulkan physical device, and then I can pass that to my class, which does it. Yeah. Yeah, I don't like to. I mean, there's nothing particularly wrong with having a static method in there for that stuff, but it does get confusing when you have that plus a constructor at the same time. Because when you look at the class, you're thinking, oh, in order to use this class, I need to make an instance of it. But in reality, you can't make an instance of it until you've called the static method in it, which at that point, just put the static method in a static class, in a static utility, and then use it from there, right? Because then it makes more sense then to do that. And also by doing that, it could have that static method create an instance of a class as its return. Okay. So we're going to start out with, it looks like physical device here. So I got to go to the, where's the, there we go, chapter 3. We got device. Instance. We've already done that. Physical device. Okay, so let's start with physical device. And then here. All right. And I guess I will. I guess I'll just make a package for it. I mean, it doesn't hurt. It doesn't necessarily help either, but it doesn't hurt. Do that. Physical device. Okay. And then we have a couple properties here. Okay, extension properties. Extension properties. Or, well, device extensions, we'll call it. VK physical device memory properties. Oh no, there's a physical device memory properties too? Great. Yeah, that's awesome. And then that is not with a buffer. Memory properties. VK physical device. Is that just a regular? Yeah, it's just the first and the last one to have a dot buffer there. Okay, so physical device. Device features, device properties. Properties, device features, device properties, and then Q family properties buffer. It's just a Q family properties. All right. And then I've taken a VK device in. So, oh, is that a? Oh, I see. He made the constructor private. Oh, so that, okay, that's why I did that. And then the static returns an instance. So really, this is just like get instance. Basically, in that case, it's not as bad. Yeah. Available devices. Yeah, that's not bad. The thing is here, I don't know that I would, it's kind of a hard one, but I don't know that I would even have a constructor then. Right. Like, sure, it's private, nobody can call it, but I would basically just make this an init method, because that's all it really is. Make that a private init method and call this get instance, right? And then just roll with that and have this populate all that stuff. Like, there's no reason, like they set the physical device up here, which is just kind of weird. There's no reason to do that if you've already done it. Right? Like, if you already retrieved it, there's no reason to go back and do it again. Or not, it's not going back and do it again, but there's no reason to, like, separate that from where you actually retrieved it. Like, you got it, like, here, and you're creating it here, right? So it's just like, just freaking set it and just be done. You know, I mean, you're inside the same class, just like, oh, you know why they're doing that? First of all, they spelled physical wrong. No, they didn't. Did they? No, why does that look wrong to me? That's not wrong. That's correct. No, you know why they're doing that? They're doing that because it's a static context versus a non-static context. That's why they put it there. Yeah. Yeah, because that's you would have a mismatch between the static context and the Does this, I bet this populates the other things too, right? Wait, where does it, yeah, that's, so it's not, because it's not populating anything in here, right? It's only populating those up in a constructor. And it's populating them based on the physical device that's passed in. Physical device properties. Okay. Physical device features. Yeah, that's doing all the population of the variables. So create physical device. It's calling physical device here, physical device there. And we're enumerating the physical devices, Okay. Try to make sure there isn't other calls to these other things that we're just duplicating. And these are just, these are non-static. Yeah, I assume these features and stuff are going to be used later, so I'm okay with breaking them out in here. But yeah, this like the rest of this crap I'm putting in a utility. Like, there's just no reason to have the static methods intertwined with the rest of this nonsense. Like, it's just you've made a class that's more, that on the surface is harder to read than it should be, right? Because you've got multiple things going on here, right? Because it seems to me like the reason for this existing is to be essentially a Pojo holding on to these things, right? So then you've got what is essentially a Pojo here, and then you're also shoving all this other operational stuff in there, which would probably be better served just, I mean, they're static methods. It'd be better served to just put them in a static. See, he's got this as protected, which tells me that he's going to extend this at some point. Unless that was just a typo on his part. Because he could be extending this class at some point in the future, but like, yeah, no, I don't, I you know what, I'm gonna do this the way that I think it ought to be. I'm gonna take those static methods out of there. We'll make a utility class for them, and I'll just do the things that make this as close to a Pojo as I can make it, so I don't confuse myself later on down the line when we have to eventually come back in here and do stuff. Yeah, that's just weird. That's I get it, and I could see the mindset that led him down that path. But it's, and for when you're trying to learn something, it makes sense too to have less classes that you're making people jump through. But from a maintenance perspective, that's just kind of asking for trouble later on. You know what I mean? In my opinion. Others may feel strongly the other way. So physical device. So what we're going to do is we're going to make this a public constructor then. Actually, what am I doing? I can just tell it to do it for me. Make a constructor with physical device. Boom. There we go. Alright. And then memory stack here. And buffer malloc int. What is this? Int buffer. It's just int buffer. Okay, whatever. Physical device properties. Colic. Alright. Equals device. Wait, am I right? Oh, no. Wait, what? Oh, I see. And okay, get physical device properties. What's this? It's probably VK11, or in my case, VK14. Okay, get physical device properties, right? Physical device and then device properties. Okay. Device extensions. Okay, so enumerate device extension properties. Device extension properties. Physical device, string null, int buffer, null. To get number of device extension. Oops. And then device extensions is VK extension properties colic. Int buffer get 0. Okay, that tells it. So it's got the size from the int buffer that came back. Okay. Okay, so equals VK. What is it? VK extension properties. Okay, and then And then we have to call it again to populate the actual extensions. Right. Which is a running theme. Device extensions is the last one. Yes. And then Q family. Get physical device Q family properties. What? Get physical device Q family properties. Get physical device Q family properties. Physical device int buffer, no. And then Q family properties, okay. Okay. And then call it again with that. So do this, and put the Q family properties at the end here. Make sure that that's the same. Yeah, that is the same. All right, and then physical device features. Device features. Oh, I'm jumping ahead here. I need to colic on that, and then it just populate it. Okay. So all right, and then physical device memory properties. So VK memory properties. Physical device memory properties. Okay. Properties properties, physical device, and properties. Okay. And then that's it for that constructor. Cool. Did we get everything? Assignment never accessed. Yeah, okay, that's fine. At least it's assigned. Okay, so have that, and then I need to grab the clean up here. So plug void cleanup. Just basically call free on. Okay, so memory properties, physical device features, Q family, device extensions, and then physical device properties. We don't free the physical device itself? That's interesting. Because we have, let's see, 1, 2, 3, 4, 5 there. And we've got 1, 2, 3, 4, 5, 6 here. So we don't clear up the physical device. That seems incorrect. Potentially. But maybe it doesn't have a free method. I don't know. I'm gonna add that in there though. So became memory properties. So memory properties free. Physical device features free. Q family props. Oops. Device extensions free. God damn it. And physical device properties. Okay, yeah, physical device doesn't have any free method. Okay, so that's why that's not there. He's got some getters on things here, so physical devices, physical device features, Q family props. So first of all, those getters are easy enough to generate, but get device name is physical device properties, get device name string. Okay. So let's do public string get device name. What is it? Oh, device name string. Wait a minute. Physical device properties. Okay, and then has graphics Q family. It has swap chain extension. Okay. So we'll say, let me see here. Yeah, so that's just a boolean. Which makes, wait, why is that? Oh, those are private. So those are for the other thing. They're not for... Those are for the utility. Wait. Why are they just private and not static then? Yeah, they're only referenced in create a physical device. So physical device to get device name. But that's calling... Oh, yeah. No, it's calling from here. Yeah. Oh, I see what you're doing. Well, they made it... And this is why you don't do this shit. They made it private because they happen to be within the same class. It's just like, just make them public methods. Who cares? It's just returning a boolean for criminy's sake. You know what I mean? Like, yeah, you know, it's like a non-destructive thing. So why wouldn't you just make it public, move all that other crap out of there? It's just it's the small things that annoy me sometimes. All right, so we're making that public. Has graphics Q family. Should I just... Why don't we just... Instead of being so technical about it, how about we just say... Is graphics capable? Like... Has graphics Q family... K... LMB, you know, like, like, is graphics capable? Done. You know, and then this other one is basically render, you know, in fact, is there even a point to separating those two? I mean, they call it different things, certainly. Okay, here's what we're going to do. Boolean is... what do I want to call this method? We'll say, is game ready? And then we'll do private Boolean, and then we'll do the has graphics Q family. All right. Then number of Q families. Is the capacity on the properties or 0? Can I just iterate? Is this... Do I have to do the traditional for loop on there, or this might be one of those things where they don't have it set up properly and I have to use the traditional for loop. Let's see. Family properties. What is it? Q family properties. Does it do a stream? Yes, it does. All right, so I don't need to do that other crap then. Okay, and then all it's really doing is looking for the Q graphics bit. Once it finds the Q flags. It's not, does not equal 0. Okay. Okay, so we want to do stream find no, I think I have to do filter Q flags. So it'd be, what is the name of this thing? VK Q family properties, Q flags, and VKQ graphics bit. Q graphics bit. It's not equal 0. All right. It's gonna let me do that. I don't think it's gonna let me do that. Yeah. So I have to do the long way. So we'll do P dot Q flags. Filter No, wait. That's not right. Because that would filter them out. I don't want to filter them out. I want to. I want to check that they're there. So I want to do collect. Right. Do I want to collect? Or no. Match. Any match. So what does that return? Any match. I don't even know. Let me see. Java lambda any match example. Let's do this. I've not used any match before, so I need to learn this. So it does return a boolean, right? That's what I figured. Check whether any element in the list satisfies a given condition. Yes. So I can just return. I can just return that. Any match to the answer. Yeah, okay, that's what I thought. That's what I thought. So I can just say here, just return. Like that. And hopefully I can do the same thing with the swap chain extension. We'll have to see if it has a stream thing on it or not. So it has KHR swap chain extension. All right, and that goes against the device extensions. Device extensions. Stream. Any match. Here we go. Oops. We're checking extension name. Okay. KHR swap chain. So KHR swap chain. Okay. Extension name. Just equals, right? Equals e dot extension name string, right? Yep. Okay. All right, and then here we just say return as graphics queue family ends as KHR swap chain extension. Boom. Done. Done. So then when we call that up here, I just have to call the one method, which will call the two that it needs under the covers. Okay. All right, and now we just need to do the actual static methods, put them outside the thing. Oh, I need to do getters on here too. Let's do that. Insert some getters. I'll just put getters on all of them. Why not? Why not? Okay. So we have that. So then, in the, should I put that in the Vulkan utils? Preferred device name. Devices get. Let me see. See, I'm not going to be returning a actual I'm not going to be returning a physical device. I'm going to be returning a VK physical device, which then can be pumped into the constructor for that. Right, because they're not. Device get device name. For device name equals device name. Now they're pumping that into there. Yeah, it's calling cleanup on the non-selected devices. Where does GIF physical devices? It's called right there. Hmm. How do I want this to be? I feel like, okay, so I feel like get physical devices qualifies as a utility method because you're passing it an instance and you're passing it in the memory stack. What is it doing with instance? Get VK instance. Okay. I see. And it's just returning a pointer buffer. Okay, yeah, alright. So here's what I'm going to do. What am I going to do? Yeah, okay, so I'm going to take this method, put it in the Vulkan util class. And this one, since it manipulates the physical device after it's, and it calls cleanup on it and stuff like that, I'm going to change the name of this to get instance. I'm going to make the constructor private and basically put this in this one method here. Get device name. We're doing that just so, well, they are testing it against the preferred device name. Which I see, I know why they're doing this. They're doing this because you want to be able to save it to, like, the options later on, you know, and be able to keep reusing that same device every time you don't want to have to find the device every time you do this, which is the one thing that's kind of bothering me here a little bit. Is that it's going to enumerate all the physical devices, even if you have a preferred device name, but it's bringing them back as a pointer buffer, so it's not a big deal there. Then it's doing it, so it's creating a VK physical device. Is that a? So that must be a, okay. That's an LWJGL thing, I guess. So it's creating that with the. It's taking that physical device, and then it's doing new physical device on it, which I. Oh, this seems very wasteful. Like, very, very wasteful. It's doing physical device get device name, which is enumerating what? It's got this guy here. Get device name is doing the device properties. Device name string. Device features. Like, this seems very wasteful. Like, if you're looking for a particular device by name, then we're populating all this bullshit for things that are never going to match that device name. Like, I get that we have to query the features too to make sure that it's not even the features. We have to query the Q family properties and the device extensions, right? So Q family properties, device extensions. So the device features, is that even being used? Not here. I mean, eventually, these are definitely things you want. But you don't want them for every goddamn device. You just want them for the device you care about. Device extensions. And then device properties. What does that come into effect with? That gives me the device name string. So we have the physical device, we have the device properties, and we have the device extensions. Right. And then the Q family properties. And what are they doing? They're saying the device name, and then they're checking that, and then they're checking preferred device name, assuming it's not null, which that should be the other way around. The preferred device name does not equal null, and it's equals device name should be the first if statement. Right? No, no, it should be pulled out of there. It should be pulled out of there entirely, right? And just say, like, if it's not null and it equals that device name, then check to make sure it's game ready. really just combine those ifs. Yeah, there's no reason to have a nested if there. Right? Just combine those two ifs. But they're saying, like, else... what are they doing there? No, I see. So they're... God, that's so convoluted. Just write it correctly. Like, it's just like... You're doing the check to see if it's game ready. You're doing a check for a device name if the device name exists. If a preferred device name is passed in. So we have a case of we've passed preferred device name in, which means we've already gone through this rigmarole at some point in time, and that's the one that we want. We just want to make sure that still supports gaming, which is, I mean, it should, but you can still query it just to make sure, right? And then that's what you want selected. Yeah, they're doing they're doing a break there too. Yeah, I would see. This is the stupid way to do things. This is the we're not worried about doing things perform it way of doing things. Like, it's just not. If you take a step back and look at it for just 2 seconds, you'd see that what you really want to do is you want to drop out of here quickly if a preferred device name is passed in. In fact, I would even go so far as to say have an overridden method here where you have one method that takes just an instance and no preferred device name, and another one that takes both, and then handle the nullness of that. If it has a preferred device name, just run through, find the freaking device with that freaking name, and just return that. And then check the graphics family and stuff. You can build the physical device thing like we're doing, but just be smart about it. Yeah, I don't like how this is. I mean, for illustrative purposes, this makes sense, but if you spend even 10 seconds looking at it, it's just wrong. That's the problem. It's like, and this is why I don't copy paste it. That's why I type it out. There are certain things I will copy paste, but this stuff, when I'm trying to learn, I don't copy paste because it's too easy to overlook obvious stupid decisions, right? And this is just kind of one of those, right? Like, it's an understandable decision because they're writing a book and they're trying to make it as plain Jane as they can. But when you're trying to make something that isn't going to be a freaking hog, you don't do it this way. Like, this, it's just silliness. Like there is a utility to having all the devices that are game ready available, because yeah, there will be people that have multiple GPUs, and you know, I have seen games where there's a drop down list in the options menu where you can select what device you want to use. So it's definitely a valid thing to have, but 99%, like even they are like dropping out after they pick the first one, right? Eventually, right? It's like 99% of the time, the first one you find in the system is probably going to be the one that you want to use. And once someone selects something from an options menu and says, this is the one I want you to use, and it's not the first one you came across, you're going to save that device name. And the next time they start up, you're just going to keep using that same device. You still have to check to make sure the device is still physically capable of doing what you originally enumerated it could do, but there's no reason to go through every friggin' physical device again. I mean, there's no reason to build up a class with all these properties in it if you haven't found the physical device you care about. Like, yes, you still have to loop over the devices as far as Vulkan is concerned, but I'm not required to build a whole object model up and then toss it out. You know what I mean? It's like, that's what they're doing. They're building this whole object model up and doing all this stuff, and then they're tossing 99% of them away. And I'm wondering if this get physical devices actually gives me something to work with. I mean, it probably doesn't, which is probably why they're doing it this way. But see, this is bringing back a freaking pointer. You know, it is what it is. Goddamn C devs taking shortcuts. But so that brings back a pointer to the physical devices. And so then up here, they're looping over and actually creating the physical devices. Which, to be honest, I would maybe I pull this out of here and put it down here. Like, is there really any value in returning that pointer buffer? Is what I gotta ask. Like, is there really any value in returning that? Wouldn't this be a better method if it just returned a list of VK physical device? Because that's the first thing you're doing with it anyway, is you're calling get physical devices. You're checking the capacity of it, which again, I can just return an empty list, which is a lot easier than doing this check, right? And then the first thing you're doing is creating the VK physical device. So why not just put that in the damn method? Just return a list of VK physical device or an empty list if there's nothing there, and shove off. All right, and then we can query that for the device name theoretically. Although, looks like the device name. Yeah, we have to. That hurts me a lot. So we still have other things that we need to do with the physical device thing. Like it needs to be needs to be like I'm going back to thinking there needs to be an init method that only initializes the bare minimum of nonsense that we need. That's so silly. Now, I'm not talking about this code here. I'm talking about the Vulkan code. That's so silly that it would be like, here's a list of physical devices. And you're like, well, great, but I only care about, I already know the list of physical devices because I've done this already once. I just want a particular physical device. And it's silly to me that there's not a way to just get a particular physical device by a device name. They're just like, here, like, we did the bare minimum. Congratulations. Like, what? Like, when would that ever be? Like, the only time that would ever be useful is if you're doing it for the very first time. After that, you're not doing that every single time. Like, that's just like, it feels like that's the kind of thing that I would expect like a hardware engineer to do, right? So like, well, it's just, we do it the same thing every time. It's like, well, there's an optimization here. Like, well, no, just do the same thing every time. Who cares? It's hardware. You know, and not really thinking about how that hardware is going to actually be used. This, by the way, is the normal day of a software developer. A lot of bitching and moaning. A ton of bitching and moaning. But all this bitching and moaning is getting me to a point where, in theory, I'm writing better code. But, you know, you still gotta go through the process. You still gotta throw the darts to get the points on the board. At the end of the day. At the end of the day, there's still a price to be paid. Usually it's mental health. And if the hardware engineer is not paying the mental health price, and the device driver developer is not paying the mental price, guess where that snowball is rolling down to? Oh man. All right, so all right, let's get this method. This method looks correct. So let's put this into our utility here. So get physical devices. But I'm not returning a pointer buffer. Screw that noise. So we'll just put this, for right now, I'll just put it in Vulkan utils. It might be more appropriate somewhere else, but it doesn't really matter at the moment. Public static list VK. What is it? VK physical device. There we go. This takes I think this instance is yeah, instance is Vulkan instance. So Vulkan render instance. Memory stack, was it? Yeah. Memory stack. Stack. Okay. Pointer buffer, physical devices. We need int buffer. Stack malloc int. Enumerate physical devices. Wait, haven't I already done this? Enumerate physical devices. Oh, no, that was device extension properties. I'm having deja vu because everything looks very similar. Enumerate physical devices. Alright, so fail if needed. VK dot VK hey Elder Dux, welcome on in. How you doing? How's it going, friend? I'm doing okay. It's been a decent week so far. Got some things accomplished. So otherwise been pretty good. Pretty good all around. Doing pretty good. That's awesome. I am glad to hear it. That's good. That's good. Yeah, I was playing some Avowed last night, and that game's looking fun. It's looking pretty fun. That's coming out next week. For the regular, I think it's actually, I believe it might be on Game Pass if I'm not mistaken. I think it might be, and I think it is on Game Pass. It's coming out on the 18th, I think. So that's been a lot of fun. It feels very I'm trying to figure out, the combat feels kind of like a little bit like it feels a little bit like Dragon Age, the Veilguard, only a lot better. It's a lot more fluid. Kind of a little bit like Mass Effect, just a little bit, but again, it's not, you don't have like the pause and tab targeting kind of thing going. It's very fluid in the targeting. Watching my playthrough of it, looking pretty good. Yeah, no, it's yeah. So speaking of Mass Effect, the voice actor for Garrus is one of your companions in this game. So it's like actually the first companion you come across. So that's really cool. And it doesn't have like, so like Mass Effect and like Dragon Age Veilguard had like the, like, we'll stop time and you can target people and then, set the tell your companions to use particular abilities. It doesn't have that as far as I can tell. Your companions just kind of use their abilities on their own. It's a little bit more, I think, I haven't played Dragon's Dogma, but I've seen some videos of it. It looks a little bit more like kind of like a Dragon's Dogma kind of sort of action-y thing. But it's so far it's been pretty fun. I can't wait to get back to it. Can't wait to get back to it. Yeah, and then there's the other. I think Mass Effect. There's a new Mass Effect supposedly coming out. I don't know if it's this year or if it's next year. I don't remember what they said, but I remember seeing that there was going to be a new one coming out. And I think it's going to be, if I remember correctly, I think they were going to do the Andromeda Galaxy again. Which, you know, Andromeda, for all its faults, it had some fun combat and stuff. You know, I actually enjoyed it for the combat part of it, and the story was, but it was decent enough. So I think that's what they said they were going to do, because it's definitely not. I think it's like Shepard's story is definitely done, which makes sense given how 3 ended. But 2027. Oh, it's supposed to come out around 2027. Okay. Yeah, I couldn't. I heard that it was coming out, but I didn't know when exactly they said it was going to be. So that's cool. I can't wait for that. Honestly, I mean, I still have a couple games I'm waiting for. Like this year is supposed to be Titan Quest 2, so I'm waiting for that. I am very interested in Doom Dark Ages, because it looks like they might be doing something a little bit different there. I still haven't played any of the modern Doom games. I should catch up on that at some point. But shooters, I used to really like shooters, and lately it's been like, kind of hit or miss for me with that. Like I liked Wolfenstein New Order, but the other Wolfenstein one they did, I didn't really take too much, because they kind of went into like this weird sort of direction with it, kind of thing. Old Blood, I think it was Old Blood that I didn't really take too much. I know that the co-op one I didn't even play, because I heard that was just not very good. But Old Blood, I don't think I didn't get very far in that one. I think the story got a little bit too. I think they leaned into like the gore and the weirdness a little bit too much, which is weird to say, but that's, what I mean. Yeah, you heard a lot of bad things about the co-op one. Yeah, the co-op one was, from what I understand, was just kind of like live service without the live service, basically. Like it looked like something that was supposed to be a live service game, and then they pared it back at the last minute, and it just kind of was just bland in general, from my understanding of it. But then they went and made Indiana Jones and the Great Circle, and that was fantastic. That game is just awesome. That is on Game Pass right now. That game, I enjoyed the heck out of that. Like that was such a love letter to the series, and such a good like story and stuff. It felt like you were playing in a movie. Which was really nice. Yeah, I gotta figure out. There were a couple other things. There's like there are a couple other things on my list that I just haven't like fully grasped yet. I know, like I have in the back of my head that I want to do a vanilla full run of No Man's Sky, which is going to be a lot of hours, but it's something that I've been meaning to do for a while. Because every time I play No Man's Sky, I play it for like 5 or 6 hours, and then I put it down, and then I don't come back to it the next year, and I play for 5 or 6 hours from the beginning, and then I put it down. I need something. I need to get past that first 5 hours, and they've got so much stuff in there now that I should be able to do it. I just need to have the stamina to just keep, like, if I do it like once a week or something as a stream, I'll just probably continue on there, because there's a lot of stuff like that I like in space games in there, you know, and it's just getting to the parts that I like. There's always been such a mountain to try to climb. You know, it's that those first opening hours are so slow, and I don't think they've really picked up the pace of those first hours. If they picked up the pace just a tiny bit in those first couple hours, I'd probably have an easier time of it. But you know, it is what it is. I mean, it's a sandbox open world game. It's doing exactly what sandbox open world games do. So it's not like it's bad for doing that. That's exactly what that genre does. It's just sometimes you just kind of get stuck in first gear with a game. I mean, I feel it's kind of the same way with like Moonstone Island, which I've been playing here and there. Like, that game feels like you're constantly stuck in first gear. Like, there's stuff that you want to do, but the grinding is just like, all right, well, I gotta grind some more. And they linked a lot of the grinding to like the creatures that you capture. So you capture creatures, but it's not just the creatures that you capture. You have to hatch eggs, and then you hatch these eggs, which take several in-game days to do, and then you have to wait several more in-game days for them to actually produce the resources you need to progress the game. And it's just like, man, this is this is ponderous, you know. Oh, and I do love the sandbox games too. I do really like them. It's just, it's the problem that I've had. I mean, it's the time investment problem that we have across all games, right? It's like I'm finding that I am enjoying games that kind of come in, do their thing, and get out, right? Like 20 hours, boom, done. You know, have a good 20-hour experience. I'm finding that I'm enjoying those more than the here's 300 hours, here's 600 hours, here's 1,000 hours, you know? It's just like, yeah, that's great, but there's so many games to play, right? And I guess that's my problem, is that I keep seeing, like, I keep looking at like, I'm playing a game and I'm like, this is a great game, I'm enjoying this, but oh my god, all these other games are coming out that I really want to experience as well. And you kind of have to, like, you're kind of trying to, in a way, rush through a game just so you can get to the next game, even though there's so many games to choose from now. You know, it's every year they're releasing hundreds of, if not thousands of games, and it's like you can never catch up with it, and yet there's that drive to just like, let's get this done, let's go, let's move on to the next thing, let's get that done, let's move on to the next thing. And still enjoy the process. And it's not like, you know, it's not like I'm trying to, it's not like I'm not enjoying the games. It's just that it's like, I want to enjoy all the games. I don't want to enjoy just the one game. I want to enjoy them all. I want to expand, broaden my horizons, expand my mind. All that stuff. You know, I don't want to be stuck in that like that corner of the internet where you see all these people complaining about not having games to play when all they do is play like sports games or first person shooters. It's like, well, there's thousands upon thousands of other games out there, and you've limited yourself to those tiny little genres, right? And of course you've run out of stuff to do over there. Right? It's like, just broaden your horizons a little bit. Find some other genre that you might like, you know? You're going to find a lot of things you don't like. And that's good, because now you know what you don't like. Whereas before you didn't know. That said, I'm excited that I got a Linux box set up with Bazite on it. So, and I have actually No Man's Sky running on that. So I want to. I just need to hook it up to my. It's like a little mini PC, and I just have to hook it up to my capture card, which I have a second capture card. I need to see if I can put in the external enclosure and see if they'll live together happily. And then I can have three things hooked up to capture devices. So we'll see what happens with all that. Because I would like to do that. Bazai comes with Moonlight and Sunshine. Well, Sunshine already installed, and then you can just use Moonlight to connect to it, which actually works pretty good, although you kind of have to crank it up a bit to get decent quality visuals. And then once you do that, you start to really saturate the network pretty quickly. You need kind of like a fiber optic connection inside your house a little bit for that. But it's pretty cool. The whole thing is pretty darn cool. So it's cool to see like stuff just kind of working on Linux now, thanks to Steam and Steam OS and Proton and all that stuff. Because I'm noticing even like with Windows 11, like there's some instabilities that are happening that are just these random hangups that just kill me after a while. Right? Like nothing, like I've changed nothing, and yet it'll just have these random issues. And unfortunately, my gaming rig right now is all Intel stuff, and I think I'm definitely moving away from Intel because as much as I've used Intel processors my entire technical existence, this latest generation they did just is absolutely garbage. Like when it comes to stability and stuff. And as soon like my streaming, the mini PC I bought from streaming, is running Windows 11, but it's an AMD processor, and right away, number one, it's faster, and then the Intel one I was doing, because I did have an Intel mini PC that I was using, it's immediately faster than it with Windows 11, and it's been far more stable, like far and away more stable. So now whether or not I'll move to Radeon stuff, that's another question. But what's my thought on the Steam OS? I think it's fantastic. I encourage it entirely. I am the only reason I didn't load up SteamOS on the new mini gaming PC is because it uses Arch Linux, and I want to still be able to understand what's going on under the covers. Like Arch Linux is very advanced, even for me, and I've used Linux a lot, and I don't know enough about the Arch uh, inner workings um, to be comfortable with it. So I went with Bazzite, which is another. It's a Steam OS. It's a basically a free open source version of the Steam OS, but it runs on other platforms. So I have it running on, by default it runs on Fedora, but I think you can have it. You can run it on pretty much anything you want. Um, it also runs on, the one reason it's getting the most attention is it runs on handheld devices. So you can run it on, I think you can run a version of it on your phone, but also it runs on the Steam Deck. So you can jailbreak your Steam Deck and put Bazzite on there, and it works just as well as the Steam OS does on there. And so a lot of people have been doing that just to have more control over, the operating system. They can drop into a desktop and run a browser and all kinds of stuff. It gives you more performance options and things like that. So that's been interesting. It's been real interesting. And the thing about Bazzite is it's kind of, it's locked down a little bit. Like you can add stuff to it, but for the most part, it comes as a package. So it's just like, here's all the stuff you might want, and you can choose what you want and what you don't want. But for the most part, everything's sort of, for more, for want of a better term, frozen in time. And it kind of just gives you that like nice curated sandbox to be in, instead of having to like manage a whole lot of packages and other things. But I think, but having said all that, I definitely want Valve to, and others, to just keep pushing, get ProtonDB working for more and more games, get the anti-cheat stuff working, because a lot of that's kernel level and you gotta just work with it, and just get more compatibility going for everything. Like they've got a lot of things that are compatible right now, and it's encouraging that a lot of the like Unreal Engine 5 and Godot and I believe Unity all support Linux cross compilation, to varying degrees. I think Godot is still maybe a little bit behind on that, but I know Unreal Engine does and Unity does. So it's I just want to see more of that. I want. I don't think gamers are going to switch over to Linux anytime soon. But I think enough are getting fed up with, enough people are getting fed up with like the instability of Windows, that they might consider, especially if you can find something that will hold your hand. You know what I mean? I think that's really the biggest problem, is that Linux is big and ugly and scary, and it doesn't hold your hand, which is why so many like it. But at the same time, a lot of people just they need guidance, right? I mean, that's why Mac and Apple has been so popular for so long, right? Because there's a lot of people who treat their computers like a car, right? You don't necessarily know how, you might know how to change the oil. You might know how to, do basic stuff, but you don't necessarily know how to service the engine or other things like that. And so you take that to someone who knows it. And I think a lot of people treat their computers that way, as just a tool, because they're not as invested in learning how that tool works as the early adopters were. I mean, we were all kind of early, but you talk about millennials, we were all like essentially early adopters to technology. And as an early adopter, you kind of have to know some stuff. Even if you didn't really want to know it, you kind of had to. And now we're at a point where it's so ubiquitous that it's just kind of a tool for most people. Most people just, well, I wouldn't say most, but a lot of people really just don't care, right? They just want something that just works and just does what they need, and they can get on with their lives. Just like a car, they don't necessarily care what's under the hood as long as it's reliable, stable, and gets them where, from point A to point B and back to point A again. And until Linux can reach that level, it's always going to be a year away from being the year of the Linux desktop. We'll just have to keep saying, oh yeah, next year will be the year of the Linux desktop. Oh, next year will be the year of Linux desktop. But I think distributions like what Bazelite's doing, where they're kind of curating the experience for users, and they're making it so that you really don't need to know much. You can definitely jump in and look at the bare metal if you want to, but you don't have to. And I think that will start to draw attention and draw people in. But again, that's a curated experience around gaming, not around tools. And the one thing, the thing that Windows has, the advantage that Windows has, is that you can use it for gaming, but you can also use it for art or music or software development or any other, you got spreadsheets and you got, word processing and all this stuff. And that area is where Linux will drive you up a wall, right? Because it has all the tools. They're just either very different from what you're used to, or they're kind of hokey. They kind of work sometimes, or they're just missing features that are just quality of life stuff. And it's not, it's not necessarily their fault. It's that they're constantly playing catch up, right? I mean, it's open source, and a lot of the software is free. So you're always going to be on the back foot, right? You're always going to be like trying to play catch up with paid software and developers who are 24/7 working on stuff. Well, not 24/7, but you know what I mean. So there's always going to be like a rush to catch up and all that. But until they can figure all that stuff out, where they can have a machine that not only plays games perfectly and quickly and get you all the FPS you want, but can also run all your productivity tools and all that stuff, then we'll have something to talk about. I mean, I've wanted to switch to Linux for a while, but again, it's always it's always that like, well, things work, sort of, you know. Um, even in the gaming sphere, it's like, I play a lot of games that have just newly released, right? And on Windows, that's like rolling the dice, right, as to whether or not it's going to work well. On Linux, it's even worse sometimes, right? Like games that have been out for a year or more probably work really well because they've had a chance to catch up and make changes to Proton DB and all that stuff. But, or to Proton, I should say. But playing it day one, they're not quite there yet for a lot of things, you know? Especially if it's a multiplayer game that has, anti-cheat stuff in it. And so it's as much as you want to switch, as much as I want to switch, there's some pain there still. I mean, that's just the nature of the beast right now. Now maybe Microsoft or somebody will embrace it. Like it would be a minor miracle, but at the same time it would be awesome if Microsoft said, you know what, for the next Xbox console, we're not going to do embedded Windows. We're going to just run Linux, and all of our stuff will just be in Linux. It'll be a cold day in hell if that ever were to happen. But we need something like that. I mean, I suppose Sony might. I don't know. I don't think there's any. I don't think there's any appetite for the Japanese game console makers to have anything that's off the shelf. Like I think the best thing about the Xbox was how it was spawned, right? The original Xbox was basically a PC. It was just off the shelf parts and running a version of Windows. I think it was like, a watered down version of Windows, right? I believe, if I'm not mistaken. I could be completely mistaken on that. And even though they went to less off-the-shelf parts with more generations, like with the 360 and stuff, they still kind of kept that sort of homegrownness of it. And they made it so that now you can play an Xbox game on both your PC and on your Xbox console, right? Like it's almost parity complete, it's almost in parity with one another. And that's a tremendous benefit, right? Because now Microsoft could say, like, look, we don't have to, like, we're selling consoles at a loss, and that's what console makers do. They sell them at a loss. We don't necessarily have to sell a whole bunch of consoles because our games work also on PCs that people already have, probably, because the PC gaming market is so popular. So we can just make money selling the games themselves. And Sony's starting to understand that because they're starting to release things a little bit more on the PC, like closer to where it's being released on the console. They're not quite there yet. They're starting to get the idea. And Nintendo is Nintendo. I cannot forgive them for their crimes against the emulation scene and the game preservation stuff. You know, they're all against emulators, but then, you know, they release a mini, you know, mini NES that's got an open source emulator that they just grabbed off the internet on it. You know what I mean? Like, they're two-faced. And I just, you know, they make good games and they have goodwill because they make good games, but they also force people onto this crappy hardware that barely plays the games that you're paying $60 for, full price for. And then when someone comes along and says, hey, we have an emulator and you can buy that same game from Nintendo. Nintendo gets their money, but you can run it on hardware that actually supports it, and you can get, you know, high res graphics and 60 FPS. And then Nintendo says, no, we can't allow that to happen. You know, it's just that I just can't anymore with that. Like, the Switch 2 looks like it's going to be really interesting, and I'm happy that people are going to be able to enjoy some more Nintendo games. And Nintendo games are great. I love Super Mario RPG. I love a lot of things that are made by Nintendo. But man, I am not going to buy any more from them. After what they did to the emulation scene for the Switch, and what they're probably going to do for the Switch 2, and, you know, I can't get behind them anymore. They've just been, I don't know. I have strong opinions. Like, you know, I very much feel like, I mean, there's a whole initiative to, you know, stop destroying games. And I very much agree with all of that. You know, it's like, you know, I understand that there's server infrastructure and all that stuff for some of these multiplayer games that's not easy to replicate, not easy to you know, maintain, and costly to maintain. But if you're going to discontinue something that people have paid for, you really, really need to just throw that code out there. Open source it, put it under a license that makes it so you can't make any money off of it. You know, it's been done before. Volition did it with, you know, the Free Space 2 code. And there's an open source community out there with the Free Space 2 code that is not making any money for what they're doing, and yet they're preserving that game plus making their own games on it and all this stuff. It's like, just, you know, you just got, like, it's just crazy. It's just really crazy. It's crazy that they're allowed to get away with that. They're allowed to just say, like, well, sorry, we got your money, but you can no longer, you know, this is now obsolete. It's not even that it's obsolete. This is now, we've bricked this. You know, this device is still, this software is still perfectly functional, but we pulled the plug on it. You know, it's just, it's just very, very crazy to me that they don't get more backlash for it. It really is. But we'll see. Maybe there'll be some kind of laws passed to force them to not allow things to go into the night like that, to not allow things to be bricked like that. Enumerate physical devices. So what? So I'm doing VK enumerate physical devices. Get VK instance buffer. So instance. Get VK instance buffer, and then physical devices to put on. And then error message here. Oh, I gotta get the number of the devices first. That's all right. We'll do this. You have to get physical devices. I've jumped ahead here. So this, copy that, paste that, and then this will be null because we gotta get the number of devices first. Failed to get number of physical devices. Right, and then put the number of devices there. Okay. Just call get without 0. Does that just get me? I'll put 0 there anyway. I would think it would just get me the first item. And then pop. So then I need the pointer allocated. So stack that malloc pointer number of devices. Okay, good. So then I'm going to. How do they have it up here? They're looping over number of devices. So I have a pointer there. So this is a pointer buffer. So can I do a stream on this? Devices pointer buffer dot no, this one I can't do it on. But wait, can I do what do they do here? They do get I. VK physical device. So if I get I, so that just returns a long. That returns a long. So that's really just a memory reference. Okay. We're passing to that. Okay, so then just make sure there's not a method here. Position mark limit has remaining free address size of. No, there's not. There's not. Okay. Well, we'll just do it the old-fashioned way. Say for int I equals 0. I is less than number of devices, I plus plus. Right. Yeah. And we'll say, let's do lists. Whoops. List of VK physical device. Physical devices. Array lists. Alright, so physical devices add new VK. VK physical device. Devices pointer buffer. Get I. And then what? Instance get VK instance. Why are we passing the entire instance in there if that's all we're doing? Get VK instance is just do that. VK instance. Why are we making this harder on ourselves? Just that's the only thing you're using there, so just pass that. So we just need instance. Okay. So that'll return the list of physical devices. So we just have to return that. Boom. Okay. So we've got that. That's the Vulkan physical devices. So then over here, I gotta figure out this mess. So if I do... So I give it the physical device. All right. We'll think about this. Think. So I need the name, right? Which comes from the device properties. Yeah, you know what? I'm gonna do, let's do this. Let's make this private. And we'll do public static physical device get instance. And shit, I'm trying to short circuit this. Like we need the device properties in order to check the physical device name. And that's the most, to me, in my head, that's the most important thing right now, is checking the device name. So if I can do that, so if I do, let's think about this. So if I say get instance, for device name, and I take a list of VK physical device, and then string device name, then in theory, so what I'm going to do is I want to go up here, and I'm going to, so I don't need the int buffer for that. So I'm going to, what does this return? This, oh, but this does, it just, see, this is the problem. It just populates device properties. Okay. Okay, here's what we'll do. So we'll grab these two things. I'm going to go over to the utilities here. And I'm going to say public static. What is the thing here? I need to return the actual physical device, which means I'll end up returning. Okay, this is gonna be ugly, but necessary for my purposes. So we'll get can I do a can I do a static record? Is that even a thing? I don't think that's a thing. No, it's not a thing. That might be okay, actually. I might not need it to be a thing. Vulkan device and properties. And I want VK physical device and what's the other? Why do I keep switching back to that one? VK physical device and VK physical device properties. And VK physical device properties. All right, so this will return Vulkan device and properties. Get physical device and properties by device name. And then we need, I need, a memory stack, and then the list of physical devices. Let me do a list of physical devices first. So list, okay, physical device. Okay. Oh, excuse me. Okay, device properties equals that. Why is that a problem? Not try with resources statement. Okay. Fine. Oh, that's oh, that's fine. Yeah, no, I don't need to try with resource there. Yeah, I get it. It's well, you know what I can do. Screw it. No, I actually don't want to. I don't want that to be freed up. So, so we have that. So that is props. We're doing a devices stream for each whoops. This will just be D here. Physical device properties. Actually, I can do, instead of doing for each, I can do... Because that's going to, I don't need to do this every time. Let's pull that out of there. And let's say, I guess not any match would be. Yeah, I guess any match. Right, and then we just say if props device name string. So we want if I need the device name. String device name. So if device name string equals device name, actually I can just return that, right? And then what does this return this returns a Boolean note, doesn't it? Which is not what I want. I want map. And I want if that is true, return D. Wait, do I return true? Wait, map. Actually, I think I had that right that way. Because you want that to return true if this matches. Because that'll be a map, and then I just want the first. First, and then find first or else. I don't think that's right. That was saying Boolean. is going on here? What am I doing? No, I think I need to do collect. Find first? No. No. What am I trying to do here? I'm trying to. Here's what we'll do. We'll say filter. And we'll say where this doesn't equal device name, filter those out. And that should give me a list of ones. Right, so that's two lists. Find first, or else no. Wait. Yeah, so that should give me a VK physical device. All right. So I'll either give me the device back or give me no. I feel like I made a mess of that, but we'll see. And then I just return new welcome device and properties. Matching device and properties. No, that's not going to work because it's going to go. It's not. It's not going to exit out. It needs to exit out as soon as it hits the first match. And that's going to loop over the entire list, and the properties are going to be wrong because it's going to be whatever's the last one on the list, which is not the correct thing. So I need to filter. It's not really filter. It's like, can I find? Let me see something. Java Lambda. Find first match with predicate. I just put find first after the, which didn't I do that? Wait a minute, what, filter, find the first name with length greater than 5. Oh, filter, so I have it wrong. Filter, so I do want to return true. Right, which, yeah, I do want to return true. Yeah, I don't know why I'm thinking I'm filtering it out when I'm actually filtering by it. But it would be, so filter, and then find first. And then find first is what do they call it? A terminal operation. So it won't continue looping if it gets true back. It'll immediately return. So then that should give me the right matching device and the right properties. Hopefully, if I'm reading that correctly. Okay. So then I want to, if I want to do get instance by device name, or get instance for device name. Get instance for device name. Yeah, so I'll do so think about this. Physical device. This that physical device equals Vulkan utils physical device by property, device and properties by device name. So we have devices, device name, and then I need to make a I need this to have a memory stack. Do I need a memory stack in here? I don't think so. There is a calloc being made here, but it's not using the memory stack at all, so I think I can get rid of that. Simplifies this a little bit. There we go. Oh, I can't reference this. Right. So I gotta do, what is the problem here? Adapt using a physical device. Oh no, never mind. Never mind. Vulcan. What did I call it? Vulcan device and properties. Okay. Refactor. Let's move class. We'll move it to. Hey, I guess, well, we can put under device. So Vulcan engine, device. No longer be accessible from method. Physical device and properties of a device name. That's fine. Factor anyway. And then make this public. There we go. Now it's available again. And then over here. So we have that. So then we want to do. So let's say private physical device, BK physical device, and BK physical device properties. And then this will be this dot physical device is physical device. This dot device properties is properties. All right, and then the rest of this has to move into an init. private void init. What I'll do is grab this. That here. And I'll say, if device properties is null, then grab the device properties. Otherwise, skip that. Okay. So then this just becomes call to init. Same with that. That's a lot freaking cleaner, I feel like. At least on this side of the fence. So then down here, we say return new physical device, and it's device and properties, physical device. Device properties. There, and then otherwise we have public static physical device get instance, just a regular get instance, and this takes vk physical device return new physical device. Okay, I'm a little bit happier with that. I think it's slightly cleaner. There's some funkiness here in the utilities, but I think the class itself makes a little bit more sense now. I think. So device should be declared as final. Okay. Fine. Yeah, I think that makes a little bit more sense there. Because then we're only... So when we're doing get instance for device name, we're passing in a list of devices. We're looking for that particular device name, and we're only going to spin up a physical device if we find that device name. Yeah. I do need to check for null though, right? I didn't do that. Device is null. Actually, I want that to be just an error, right? So I think there's an or else throw, right? Yes. Oh, excuse me. Oof. Isn't there, can I throw it? How do I throw an exception here? Supplier. Exception supplier. Okay. Supplier extends throwable. Okay, so new runtime exception. Unable to find matching device. Unable to find device. Physical device matching name. Check S formatted device name. Is that not? It doesn't like that. I have to do a supplier. Let me see if there's an example out there of or else throw. Lambda or else throw example. Yeah, that's doing it as that. Or else throw example with message. Yeah, that's not helping. Or else throw with message. Yeah. Oh, well, okay. They indirectly gave me the answer there. So if I just do that, that should do it. Okay. Right, so we have that. So where am I at over here now? now that I've completely got at what they were doing. Create physical device. So I still have to do the so this is doing get physical devices. Yeah, so this is the part. So this is not correct here. I need this to be basically this, create physical device. So select the physical device. All right, so this is where we gotta do. All right, physical device selected device. Try memory stack equals stack push. Get devices. So list of physical device devices equals physical devices, and that is was it Vulkan rendering instance dot why is that not doing what I wanted to do? Instance. So why is that not doing? Wait, Vulkan renderer. Wait, what's going on here? EK instance. Get EK instance. Yeah. So where are they getting instance from? They're passing that in. Oh, so I should just take that. Wait a minute. Why am I taking? Oh, yeah, that's wrong. I know what I'm doing. I know why I'm confused now. VK instance. That's what I want there. Instance in the stack. Okay. Gives me a devices back if that's empty. If devices dot is empty. Row new runtime exception. No physical devices found. Okay. check for device name because this will be, there is no device name. But I do need to grab the device. Well, no, I don't even need to grab the device name. I just need to check if the device is game ready, basically. Let me add that to the list of physical devices. Yeah. Okay. That's a list of physical devices. Well, we're just looking for the very first one. So why do we have a list of, well, I guess, yeah, it would be nice to have a list of the ones. But that's not the purpose of this. Selected physical device. Yeah, we're just picking the first one we come across. The purpose of this is just to get the first one we come across, not to enumerate all the physical devices. I mean, it will. Yeah. Yeah. There's a utility. There is a good reason to enumerate all the physical devices that can support what we're looking for. But this ain't the place to do it. So really we're just trying to find the first one that's graphics, that's game ready, basically, and then that's the one we'll return. So physical device. So for each thing in there, all right. So for each one of these that came back, we're saying, I want to find the first one. Well, I have to create the stuff. So it's going to be yeah. Yeah, that's the annoying part of this, that it's going to go through all the setup. But we need the device extensions and the family properties. So I guess it doesn't hurt to get all these too. So it'll be so we'll say devices for each. Why are you doing that to me? For each device. Okay, so select device equals new. Physical device D. It's not going to like that, is it? Should be final or effectively final. Yeah, that's what I thought you were going to say. All right. No. Let's be more reasonable about this. Let's just do the traditional for each. For each EK physical device and devices. Okay, then we'll do select device equals new physical device if select device that is game ready. Break. Otherwise, select the device, clean up. All right, that's essentially what we're doing. All right, and then select the physical device. No. So select the device, clean up, and then I should probably select the device equals no. Just so I have that. So if we don't find any that is game ready, then I can check for null here. If select device is null, then throw new runtime exception. No suitable physical devices were found. Otherwise, return select device. Initialize. Yeah, okay. I'll initialize it. Just so we're consistent. Okay, so I think that's the gist of it. I think. Is there anything else in there? Any other gotchas? I don't think there are. I got all of that in there. Okay, so that's good. So one class down after all that. So that's physical device. So that was this first part. Physical device, different attributes. And then Q families. Oh, well, we've done that already. Logical device. Now that you have a physical device, we can start with the logical device. Vulkan separates these two concepts, while physical device directly maps to a physical capable hardware. A logical device represents the actual interface to that hardware. Great. The logical device will store all the resources that we create alongside with their state. In case you wonder, you may create more than one logical device. It's not a layer of abstraction over our GPU. Okay. So that's the device class then that they have in there. Wrap device creation and some utility methods around it. So it takes a physical device. Store a Vulkan logical device. Use that structure for creation of resources we'll need later on. Okay. Portability, define. Okay, this is where we're defining all the extensions that we want for portability nonsense. So we're basically repeating all that same code again. Okay, I see where they're going there. So that's this class. Physical device, define extensions, set required features. And then clean up and then get device extensions. Extension name string. Okay. It seems relatively straightforward. There's a lot of just kind of repeated stuff in here that we have to do, but it's not that big a class, so I think we're good there. And then what? Logical device. And then we have to do surface. That's why the surface class had stuff in it. Okay. Surface class is taking the physical device. Oh, that's calling GLFW create window surface. Okay. For that particular window handle. Got it. And then a queue. We have to queue up stuff for the GPU. Okay, that looks fairly innocuous for a little bit here. Render modifications, and then, okay, so this is just introducing it into the rendering instance. Okay. All right, we have quite a few things left in this chapter. We've only gotten through the first subheading, basically. But it looks like the other things are a little bit more straightforward, maybe. So that's good. So just gonna save this. I'm not gonna commit this yet because we're not fully done the chapter 3 yet. But it looks like perhaps I should be able to finish chapter 3 of this tomorrow. Whether or not I'll get started on to chapter 4 is another story, but we'll see. So that'll be, at least we're still making forward progress anyway, one way or the other here. But boy golly, do they have a lot of boilerplate to try to go through to get to stuff. It's kind of crazy. It really is. It also, I mean, I understand better now why so few games even bother to deal with the Vulkan engine, because it's a lot of work for very little gain. You know? I mean, yes, technically there's a performance gain in there, but the reality of the situation is there's a lot of laziness in this API. I feel like they you know, kind of copped out and said, well, this is the more performant way of doing it, instead of, you know, coming up with a solution that was performant and also not a complete pain in the ass to implement. You know, so someone somewhere got really lazy, I feel like, during this process, and now it's everybody's problem. My 2 cents on that. But all right, so we got a ways to go yet. We gotta get all the way to like chapter 9 before we can actually get into parity with the OpenGL engine. And the OpenGL engine, I was rendering that thing out, what, at chapter 3? That's a lot. That's a lot of boilerplate you have to go through for this. And then in the back of my mind, I'm thinking, like, how much of this is actually useful and how much of this is just there to illustrate the API and not actually useful for in a production sense of the term, you know. But that is that. That is that for tonight, my friends. Thank you so much, everyone, for watching. I appreciate it greatly. If you do happen to run across this on the old YouTubes, and you can spare a like and or a subscribe, that would be even more awesome. That helps out tremendously. It would be great, and I appreciate it highly. I don't see anyone on Twitch live right now, so I'm just going to let you guys disperse on your own here. And thank you again, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And I hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, See you, bye.
Same old story. Boy finds girl, boy loses girl, girl finds boy. Boy forgets girl, boy remembers girl. And girl dies in a tragic blimp accident over the Orange Bowl on New Year's Day.
Good year.
No, the worst.